Hello friends, I am Dr. Dinesh Kumar Mishra, Professor Pharmaceutics, College of Pharmacy, IPS Academy, Indore. I am back with another episode. This episode is in continuation with my previous talk. In the previous lecture, we have talked about the basics of semisolid dosage forms, their properties, classification, mechanism of skin penetration, and factors affecting drug penetration through skin. So in this current episode, we are going to talk about semisolid bases and their selection, general formulation, manufacturing procedure, evaluation and packaging. So let's begin our today's episode. So let's start with our module 1, that is semisolid bases and their selections. So first we'll talk about what are these bases. These bases are nothing but these are the most important ingredients used in the formulation of semisolid dosage forms. What these bases does, the bases do not merely act as the carrier of the medicaments, but they also control the extent of absorption of medicaments incorporated with them. Now we'll talk about the ideal properties of the bases. They should be pharmaceutically elegant, they should be inert, non-irritating and non-sensitizing. They should release the medicament effectively at the site of application. They should be non-greasy, non-dehydrating, and they must be compatible with the medicaments and skin pH. They should be easily washable with the water. They must have good keeping properties and they must be stable on storage. Let's talk about their different types of bases. So first start with ointment bases. Ointment bases can be classified as follows. They are hydrocarbon bases, absorption bases, emulsion bases and water soluble bases. First one is hydrocarbon bases. These bases are classified as oleaginous bases along with bases prepared from vegetable fixed oils or animal fats. They are usually petrolatum modified by waxes or liquid petrolatum to change viscosity characteristics. These bases are expected to provide a film which resists soap and water. What are the characteristics of these bases? These are occlusive, hydrophobic, greasy, non-water washable and emollient. Bases of this type includes hydrocarbons. It may be petrolatum that are white and yellow, liquid paraffin, paraffin wax. Second one is vegetable oils and animal fats, coconut oil, olive oil, almond oil, lanolin, beeswax, peanut oil. They may be hydrogenated oils, cottonseed oil, hydrogenated castor, soybean corn oils. They may be alcohols, esters and acids includes cetyl alcohol, estryl alcohol, olyl alcohol, lauryl alcohol, glyceryl tristearate, ethyl oleate, ethylene glycol, stearic acid, oleic acid, palmitic acid, lauric acid. Petrolatum used as an ointment base has a high degree of compatibility with a variety of medicaments. They are occlusive and anhydrous and hence provide stability of medicaments. Being occlusive, they increase skin hydration by reducing the rate of loss of surface water. Despite of advantages in terms of stability and emolliencies, these bases suffer from greasiness, which may stain clothing and difficult to remove. Poor patient acceptance is also observed with such bases. So we'll talk about now second types of bases. What are absorption bases? These bases are hydrophilic, anhydrous materials that have the ability to absorb additional water, ultimately forming water and oil type of emulsions. So these bases vary in composition and are mixtures of animal straws with petrolatum. What are the characteristics of these bases? They may be occlusive, absorb water, anhydrous, greasy, and also emollient. Examples of these bases: lanolin, lanolin isolate, cholesterol, lanoestrol and other estrols. Acetylated sterols or partial esters of polyhydric alcohols may be used as absorption bases. The absorption bases are of two types, the anhydrous form and the emulsion form. Now we will talk about third type of bases. These are emulsion bases. There are two types, water in oil and oil in water. First is water in oil type. Lanolin and cold cream are the example of this type. What are the properties of these bases? They are emollient, occlusive, contain water, greasy and sticky, and vehicle for the medicaments. The second one is oil and water type. They are hydrophilic ointment and vanishing cream are the example of this type. What are the properties of these bases? Non-occlusive, non-greasy and non-sticky in nature. Water washable, can be diluted with water and vehicle for the medicaments. Let's talk about fourth type of bases. They are water soluble bases. As the name is indicating, they are made up of soluble components or may include gelled aqueous solutions. These bases are prepared from mixture of low and high molecular weight polyethylene glycols, which range in their consistency from liquids to solids. Their water solubility is due to the presence of many polar groups and other linkages. What are the properties of these bases? They are usually anhydrous, water soluble and washable, non-greasy, non-occlusive and lipid free. Now talk about the second type of bases, that are suppository bases. These bases can be broadly classified as oleaginous or fatty bases, aqueous or hydrophilic bases, emulsifying or water dispersible bases. First one is oleaginous bases. Theobroma oil or cocoa butter is one of the most widely used bases, although it fulfills the criteria of an ideal base, but it melts below body temperature. Overheating may alter its physical properties and having tendency to mold adherence. They may exist in 4 types of crystalline form: alpha, beta, beta dash and gamma crystal, and they also show polymorphism. Various forms of cocoa butter available, they depend upon degree of heating, cooling process, conditions during this process, and all the 4 forms are unstable and converted to stable form over a period of several days. Generally, the minimal use of heat during the melting process is recommended. Second type of suppository bases, that are aqueous bases. First one is glycerinated gelatin. It is usually a mixture of glycerin and water, which is converted into stiff jelly by the gelatin addition. Gelatin content can be varied as per desired use of preparation. Usual composition of this base is 14% gelatin, 17% glycerin and water. Sometimes it may be 20% gelatin with 70% of glycerin. The incompatibility of certain medicaments can be avoided by the selection of either pharmagel A, that is cationic, or pharmagel B, that is anionic form of gelatin. This type of base does not melt at body temperature but dissolve in the secretions of the body cavity in which they are inserted. Glycerine suppositories are liable to mold growth, hence preservatives to be added in the preparation. Second example is soap glycerine. In this type, soap is used in place of glycerine for hardening. Third one is PEG bases. Polyethylene glycols are used under the trade names of carboxyls, macrogols and postanols. Third type of bases, that are emulsifying bases. These bases are marketed under trade names of mesaestrinum, bitupsol and mesopol. Water dispersible bases essentially consist of surfactants and melt at body temperature. The bases can be used for formulation of both water soluble and oil soluble drugs, example twiins and spans. These surface active agents may be used alone, blended or used in combination with other suppository vehicle. Now how we can select the bases? The selection of bases is the optimum base requirement compromises in drug formulation. Stability or drug activity might be superior in a hydrocarbon base. However, acceptability is diminished because of the greasy nature of the base. The water solubility of the polyethylene glycol bases may be attractive, but the glycol may be irritating to traumatized tissue. Drug activity and percutaneous absorption may be superior when using a hydrocarbon base. However, it may be prudent to minimize percutaneous absorption by the use of a less occlusive base. There are certain factors that govern the selection of optimum base for formulation. What are those factors? First factor is dermatological factor. In dermatological factors, first one is absorption and penetration. Absorption means drug entry into the systemic circulation, that means bloodstream, while penetration means drug passage through the skin, that means cutaneous absorption. Common facts related to this factor are: first one is medicinal agents soluble in both oil and water are readily absorbed through the skin. Second, water soluble substances are more readily absorbed from aqueous bases. Third one, medicaments are more readily released from oil and water bases than from water and oil or greasy bases. Fourth one is animal and vegetable oils when combined with water normally penetrate the skin. Now second factor is effect on skin function. Greasy bases generally interfere with the normal skin functions like heat radiation and sweating. They may be irritant to the skin. Oil and water emulsion bases or water miscible bases produce a cooling effect and mix with skin secretions. Third one, miscibility with skin secretion. Emulsion bases are more readily miscible with skin secretions than greasy bases. This causes drug more rapid and complete release of medicament to the skin, and hence low concentration of the medicament is needed when emulsion bases are used. Fourth one is compatibility with skin secretion. In this factor, commonly neutral ointment bases are favored because of comfort in use and compatibility with the medicaments. Usually, ointment bases should have pH around 5.5, which is the average pH of the skin secretions. Next factor is irritancy. Bases should be non-irritant in nature. Greasy bases may cause irritation and edema formation. Selected base should maintain high standard of purity and bases used for ophthalmic purpose should be non-irritating and free from foreign particles. Another factor that is emollient properties. Normally, continuous hydration keeps the skin moist sufficiently. Dryness and brittleness of the skin causes discomfort to the skin. Therefore, the ointment bases should possess emollient properties and be able to keep the skin moist. Humectants like glycerin and propylene glycol keep the skin surface moist and soft. Wool fat, lard and paraffin keep the skin soft by preventing rapid loss of moisture from the skin. Another factor that is ease of application and removal. Generally, the ointment bases should be easily applicable and also removable from the skin. Stiff and sticky ointment bases are not suitable because they may cause damage to the newly formed tissues of the skin. Hence, emulsion bases are preferred as they are softer and spread more readily over the area to which they are applied. The emulsions, particularly oil and water types, are easily removable with water. Second major factor that are pharmaceutical factors. In this, first one is stability. It is a major concern. The fats and oils obtained from animal and vegetable sources are liable to undergo oxidation. This can be prevented by incorporating a suitable antioxidant in desired concentration in the ointment base. Oil and water type emulsion bases are liable to microbial growth, hence needs a proper preservative. Similarly, ointments containing liquid paraffin may get oxidized on prolonged storage. Emulsified bases are liable to phase separation due to improper formulation or under the influence of temperature. Second example of the properties, that is solvent properties. Most of the medicaments used in the preparation of ointments are generally insoluble in the ointment bases. Hence, for the uniform distribution, it is necessary to mix finely powdered drug in the ointment base. Phenol in solid form is quite caustic, and if present in a finely divided form in an ointment base, it may cause blisters. Therefore, it must be dispensed in a suitable base which should keep the phenol in solution form. Hence, a base consisting of a mixture of hard and soft paraffins, beeswax and lard is recommended for phenol. Similarly, in the preparation of compound mercury ointment, olive oil is used to keep the camphor in solution form. Third factor is emulsifying properties. Hydrocarbon bases can absorb only a small amount of water in comparison to animal fats, which can absorb large quantities of water. For example, wool fat can absorb about 50% of water, and when mixed with other fats can take up several times its own weight of water or hydroalcoholic liquids. Hence, wool fat is included for the preparation of base meant for eye ointment. Similarly, cetrimide emulsifying ointment is capable of absorbing considerable amount of water, forming oil in water creams. Another factor, that is consistency. Bases used should be able to provide desired consistency, neither be too hard nor too soft. Consistency withstands wide variation in temperature conditions. Therefore, in summer season, it should not be too soft, and in winter season, not too hard, to be difficult to remove from the container and apply over the skin. The consistency of an ointment can be adjusted in such a way that it contains a suitable quantity of high melting point substances like hard paraffin, beeswax, etc. in soft ointments and low melting point substances like liquid paraffin in hard ointments respectively. So after discussion of different types of bases and their selection, in this module 2, we'll talk about formulation of semisolids. What are the different ingredients that are required for formulation of these dosage forms? It includes active pharmaceutical ingredients, bases, preservatives, humectants, antioxidants, emulsifiers, gelling agents, permeation enhancers, buffers. Now, as we have already talked about the active pharmaceutical ingredients, depending upon the type of formulation, we can select API. Second one, bases, we have already discussed. Third one, preservatives. Due to high water content, there is a need of agents that resist microbial attack. Commonly employed agents as preservatives are methyl hydroxybenzoate, propyl hydroxyl benzoate, chlorocresol, benzoic acid, phenyl mercuric nitrate. Now, next one is humectants. What is humectant? It is a hygroscopic substance that is used to increase the solubility of ingredients, elevate the hydration of the skin, and to elevate its skin penetration. It is often a molecule with several hydrophilic groups, most often hydroxyl groups. Examples may be glycerin, propylene glycol, polyols like sorbitol, xylitol, polymeric polyols like polydextrose, natural extracts, lactic acid or urea. Another ingredients that can be used are antioxidants. What are antioxidants? This should be included whenever there is a possibility of oxidative degradation of the base. It may be more desirable to select 2 antioxidants instead of 1. The concentration of antioxidants would depend upon their partition coefficients between the aqueous and oily phases if both the phases are present in a base. Generally, compounds like butylated hydroxyanisole, propyl gallate, nor dihydroguaiatic acid, etc., they are used in ointment bases. Another agents that can be used are emulsifiers. These are the agents that make emulsion stable by increasing its kinetic stability. They can improve the stability by reducing the surface tension between 2 phases and by preventing coalescence of individual phases. One common type of emulsifiers is surfactants. There are 3 types of surfactants. They may be anionic surfactants, examples, alkyl sulfates, soaps. Another one is cationic surfactant, examples, quaternary ammonium compounds. And third type is non-ionic surfactant, examples, spans, twins. Another agents that can be used are gelling agents. What are these agents? These agents are hydrocolloid substances that give thixotropic consistency to the gel and form a weakly cohesive internal structure. Examples, tragacanth, sodium alginate, pectin, gelatin, cellulose derivatives, carbomer, etc. And another one is that agents are permeation enhancers. The skin generally act as a barrier and restricts entry of drugs. With the help of these penetration enhancers, drug penetration can be improved. Commonly used enhancers are menthol, carbacril, limonene, geraniol, oleic acid. Another agents that can be used for formulation are buffers. What are these buffers? They are solutions that can resist change in the pH upon the addition of acidic or basic components. It is able to neutralize small amounts of added acid or base, thus maintaining the pH of the solution relatively stable. To effectively maintain a pH range, a buffer must consist of a weak conjugate acid-base pair. Examples, they may be acetate buffer, citrate buffer, phosphate buffer. Now, why these buffers are added? They are added to the preparation for various purposes like drug solubility, drug stability, compatibility with the skin, and influence on drug ionization. After discussion of general formulation selection, in module 3 we will talk about manufacturing procedure of semisolids. In this module, first we start with ointments. How the ointments can be prepared? They can be prepared by various methods like trituration method, fusion method, chemical reaction method, emulsification method. Now we will point out one by one. First one is trituration method. This method is suitable for medicated ointments containing insoluble drug components. Finally, subdivided components are passed through sieve number 80. It is also known as levitation or mechanical incorporation method. Example is Whitefield ointment or compound benzoic acid ointment. Preparation by trituration or mechanical incorporation involves the application of pestle and mortar, ointment slab and spatula, and ointment mill. Now we move towards second method, that is fusion method. When waxy material and hard fats are to be incorporated with soft oleaginous materials, it is the best method. This method is used to melt multiple components. Components are melted in descending order of their melting point. It means highest melting point component is melted first, followed by next melting point. Medicament is slowly added to the melted base with a continuous stirring until mass gels cool and homogeneous preparation is formed. Example is simple ointment. Now move towards third method, that is chemical reaction method. This method involves formation of new products after chemical reaction. Example is iodine ointment. Next method is emulsification method. In this method, initially preparation of oil and aqueous phases is done separately. Then uniform mixing of these phases that lead to the formation of emulsion. Further emulsion is cooled and homogenized for efficient formulation. After this discussion of ointment, we will talk about paste, how paste can be prepared. Hydrocarbon bases, water miscible bases, and water soluble bases are used for paste preparation. The commonly employed techniques for making paste are trituration method and fusion method. As we have already discussed these methods, now move towards how we can prepare creams. Creams are basically emulsion, hence a suitable emulsion base can be taken, and they can also be prepared by trituration method and fusion method. So no need to discussion, we have already talked about. Now move toward another formulation, that is gels. Gels can be prepared by different methods. They include fusion method, cold method, dispersion method. After gels, how we can prepare suppositories? Suppositories can be prepared first method, that is hand molding. It is the oldest and simplest method. By rolling the suppository into the desired shape, The mass is then rolled into cylindrical rod of desired length and diameter. Second method is compression molding. Elegant suppository can be made by compression mold instrument. It is simple and having elegant appearance than hand molding. It avoids the possibility of sedimentation of the insoluble solids in the suppository's base. Another method that can be used to making suppository, that is pour molding. Most commonly used method for production of suppository on both small and large scale. First, the base is melted on water bath and then the drugs are either emulsified or suspended in it. Then, the mass is poured into cooled metal molds which are usually chrome or nickel plated. Another method that can be used is automatic molding machine. The molding operation, that is pouring, cooling and removal, can be performed by a machine. The output of typical rotary machine range from 3500 to 6000 suppository per hour. So after discussion of general manufacturing procedure, we will move towards next module, that is module 4. But before moving to our next module about evaluation of semisolids, I would like to suggest you to visit our website, that is www.cec.nic.in for further reading and learning of more topics associated with your B.Pharm syllabus. Here you will find many lectures, e-contents, LORs and many more. Hope this site will be a catalyst of learning for you. Now coming to the evaluation of semisolids. How semisolids can be evaluated? In this category, first we'll talk about ointments. How the ointments can be evaluated? They can be evaluated by physical methods first, microbiological methods second. First method, that is physical methods. In this, absorption rate, skin irritancy, penetration rate, drug release, rheological property, content uniformity. First one is absorption rate. How it can be calculated? Formulation can be applied over a definite area of the skin by rubbing, and at regular time intervals, serum and urine samples are analyzed for the drug absorbed. Second one is skin irritancy test. This study is evaluated by patch test. In this test, 24 human volunteers are selected and definite amount of formulation is applied under occlusion daily on the back or volar forearm for 21 days. The type of pharmacological response is observed and no sign of erythema or edema should occur. Third parameter, that is penetration rate. It is determined by flow through diffusion cell or microdialysis method. Animal or human skin of definite area is taken and tied on diffusion cell. Cell is placed in a fluid bath and definite amount of formulation is applied on skin. The amount of drug penetrating through skin is analyzed at regular intervals by taking samples from fluid using a spectrophotometer. Another parameter, that is release rate. A clean test tube is taken and the internal surface is coated with the formulation as thin layer. Saline or serum is poured into the test tube. After certain time period, the saline is analyzed for drug amount. Amount of drug divided by time period, it gives the rate of drug release. Another property, that is rheological property. It is very important characteristic for any formulation. Viscosity of formulation should be such that it can easily be removed from container and easily applied to the skin. Viscosity can be determined by the use of viscometer. Another parameter is content uniformity. A known amount of formulation is taken and assayed for drug amount. Second major parameters that can be used for evaluation is microbiological methods. In this, first one is microbial content, second one preservative efficacy. How we can determine microbial content? Solutions of different samples of the formulations are made. Each sample is inoculated with the separate volume, that is 0.5 ml of rapid plasma under aseptic conditions and incubated at 37 degrees centigrade for 1 to 4 hours. Absence of microorganisms is confirmed when no clot formation is indicated in the incubated mass. Second parameter for evaluation is preservative efficacy. Initially, number of microorganisms present in the formulation is determined by pour plate technique. Then, solution of different samples of formulations are made and mixed with tryptone azolactane broth separately. All microbial cultures are added into each mixture under aseptic condition and incubated. The number of microorganisms present in each sample is determined on the interval of days 7, 14, 21 and 28 days of inoculation. After discussion of the evaluation of the ointments, we will move towards gels. How gels can be evaluated? First method is pH measurement. By the use of digital pH meter, we can determine the pH. Second one is drug content. It can be analyzed with the help of UV spectrophotometer. Third parameter, that is viscosity. With the use of Brookfield viscometer, we can determine the viscosity. Next parameter is spreadability. How it can be determined? It is expressed in terms of time in seconds taken by 2 slides to slip from the gel placed in between the slides under the direction of certain load. Lesser the time taken for separation of two slides, better the spreadability. Spreadability is used to denote the extent of area to which gel readily spreads on application to skin. It can be calculated with the help of this following formula. S is equal to ml by T. What is this M? M is equal to mass tied to upper slide, L is equal to glass slide's length, and T is equal to time taken to separate the slides. Another parameter is extrudability study. Capability of formulation to extrude easily from container is determined. It is determined in terms of weight in grams required to extrude a 0.5 cm ribbon of gel in 10 seconds. Another important parameter for evaluation is skin irritation test. Formulation is generally applied on the skin and tested for any kind of sensitivity, reactions like erythema, edema, etc. Another important parameter for evaluation is in vitro diffusion study. It can be done with the help of French diffusion cell. It is very important parameter for any formulation, that is stability. It is major concern. It is tested at different temperatures. After evaluation of gels, we move towards creams. How creams can be evaluated? First parameter for evaluation is viscosity. With the help of Brookfield viscometer, we can determine the viscosity. Second one is skin irritation test. Formulation is applied on skin and tested for any kind of sensitivity like itching, rashes, irritation or redness. Third important parameter is biological testing. Tested mainly for preparations containing hormones, vitamins and antiseptics. Another parameter, consistency and stability. They can also be used for evaluation parameters. Now we'll move towards suppositories. How suppositories can be evaluated? First parameter for evaluation is melting range test. It is also known as macro melting range test. In this test, measurement of time taken for the entire suppository to melt when immersed in a constant temperature, that is 37 degrees centigrade, water bath. In contrast, micro melting range is the melting range measured in capillary tubes for the fat base only. The apparatus that is used for measuring the melting range of the entire suppository is a USP tablet disintegration type of apparatus. Second parameter, that is liquefaction or softening time test. U2 partially submerged in a constant temperature water bath, a constriction on one side holds the suppository in place in the tube. A glass rod is placed on the top of the suppository and the time to pass through to the constriction by rod is noted as the softening time. It is usually carried out at 37 degrees centigrade. Third test that is used for evaluation is breaking test. It is designed as a method for measuring the fragility or brittleness of the suppositories. The apparatus that is used consists of double wall chamber in which the test suppository is placed. Water at 37 degrees centigrade is pumped through the double walls of the chamber and the suppositories contained in the drug inner chamber supports a disc to which a rod is attached. The outer end of the rod consists of another disc to which weights are applied. The test is conducted by placing 600 gram on the platform. At 1 minute intervals, 200 gram weights are added and the weight at which the suppository collapse is the breaking point. Another parameter is dissolution testing. The pattern is measured by using the same melting range apparatus. If the volume of water surrounding the suppository is known, then by measuring aliquots of the water for drug content at various intervals within the melting period, a time versus drug release curve can be established and it can be plotted. Coming to the next module that contains packaging of semisolids. So another important parameter, that is packaging for any formulation. An ideal container should protect the product from the external atmosphere such as heat, humidity and particulates. It should be non-reactive with the product components and be easy to use, light in weight and economic. Now what materials can be used for packaging? It includes jars. It may be made up of glass, plastic, disposable jars, usually of plastic, tubes that are made of plastic, tin, aluminum. Now we'll talk about individually, formulation wise. First is ointments. Ointments can be dispensed in wide mouth jars or tubes of adequate size or in collapsible tubes. Care should be taken when dispensed in jars and not to allow the contact of the formulation with the cap liner. The cap should be tightly fitted after use to avoid evaporation of water. Next, creams. Creams, how they can be packed? They can be packed in tightly closed container to avoid water loss. Collapsible metal or plastic containers are preferred, and when a pot with a screw cap is used, care should be taken to ensure that the liner of that cap is of plastic or coated with the plastic. Next one is gels. How gels can be packed? Being viscous and non-Newtonian system, gels need high attention. during packaging into container. Usually they are packed into squeezed tubes or jars made of plastic materials. Aluminum containers also used when the product pH is slightly acidic. Pump dispensers and pre-filled syringes are sometimes used for packing gels. Most of the gels contains aqueous phase, hence should be preserved in airtight containers to protect from microbial attack. This should be preserved at room temperature and protected from direct sunlight and moisture. Next one is suppositories. How suppositories can be packed? They must be placed in container or wrapped in such a manner that they do not touch each other. Wrapping materials can be tin or aluminum and non-absorbent paper or plastic strips. Overwrapping is done by hand or machine. Many suppositories are not individually wrapped. In such cases, they are placed into cardboard boxes or plastic containers that have been molded to provide compartment for 6 or 12 suppositories. Suppositories should be protected from heat, preferably stored in the refrigerator. Glycerinated gelatin suppositories should be protected from heat, moisture and dry air by packaging in well-sealed containers and storing in a cool place. Now it's time to summarize our talk. It is vital to select an appropriate base for the semi-solid preparation based on its dermatological and pharmaceutical properties. Apart from medicaments and bases, certain other additives are needed for effective and stable formulation like preservatives, antioxidants, humectants, gelling agents, buffers. Manufacturing procedure is adopted according to the type of dosage forms, generally titration method, fusion method, chemical reaction method and emulsification method are employed for the preparation of ointments, creams and paste. Quality control evaluation is mandatory to ensure the quality of the product for specific purposes like leak test, spreadability, drug content, rheological behavior, microbial limit test, etc. Packaging of dosage form is another important aspect which should be considered to ensure safety of the product as well as convenient to the consumer. In summary, this module will help students to understand about semi-solid bases and their selection, formulation of semi-solids, manufacturing procedures, evaluation of semi-solid products, packaging of semi-solid products. Now let's have LORs with answers. Question number 1. What are semi-solid bases? Bases act as vehicles to deliver the drug and to impart emollient and lubricant properties to the formulation. They are one of the most important ingredients used in the formulation of semi-solid dosage forms. Bases do not merely act as the carrier of the medicaments, but they also control the extent of absorption of medicaments incorporated with them. Question number 2. What are the criteria for selection of suitable base? Selection of the optimum base requires compromises in drug formulation. There are certain factors that govern the selection of optimum base for formulation. They may be dermatological factors, pharmaceutical factors. Question number 3. What are penetration enhancers? Penetration enhancers are those substances that penetrate through skin to decrease the barrier resistance and also interact with skin constituents to promote the drug flux. They may be ethanol, surfactants, oleic acid, terpenes, glycerol, etc. Thank you very much.